In this video, we are going to talk about graphing tangent functions. We've done sine and cosine already. So let's take a look at just the tangent of x. Off to the side here, let's evaluate from the unit circle here first for a few values of tangent and then plot those points. So if we take a look at tangent of pi over 2, so pi over 2 is the same as 90 degrees when we're talking radians. And this ordered pair is the ordered pair 0, 1. And then remember that tangent is on the unit circle is actually the y coordinate divided by the x coordinate. So for tangent of pi over 2, our y value is 1, our x value is 0, 1 divided by 0 is undefined. So when you go to plot an undefined point on a graph mathematically, that's going to have an asymptote. A value doesn't exist there. So we'll plot those in a little bit here. So then let's evaluate at pi over 4. So pi over 4 is the same as 45 degrees. The ordered pair here is square root 2 over 2, square root 2 over 2. So when we do y divided by x, we have the exact same number divided by itself. Anything divided by itself is 1. So tangent of pi over 4 is 1. Tangent of 0, so the ordered pair here is the ordered pair 1, 0. Y divided by x, so we'll have 0 divided by 1, which is 0. Then we're going to get negative pi over 4. So negative pi over 4 is back pi over 4, so that's going to be the same exact ordered pair as pi over 4, but this time the y coordinate is going to be negative. So now we're going to divide the same number, but 1 negative, 1 positive, so this is going to be negative 1. And then negative pi over 2 would be here at 0, negative 1. So we're going to have negative 1 on top, 0 on bottom, which is again undefined. And then this is actually going to keep going on the other side. And so tangents period actually just repeats itself every pi units or every 180 degrees. So the normal period for tangent is pi. So let's take a look at graphing this. So first off, I've given you a graph and I've labeled the scale. So we see negative pi here. We need to get to pi over 2 and pi over 4. So I want to split this out and figure out where those are right now. So if pi is 8 boxes, so I've counted here to 8 boxes, then pi over 2 is half of that, okay, at 4 boxes. So here's pi over 2. So then here would be negative pi over 2. And then pi over 4 is halfway between that, okay? So pi over 4 is half of pi over 2. So that's going to be here at 2 boxes. So let's go ahead and graph these points here. So now, like I said, for undefined, so we're going to go to pi over 2. Tangent is undefined at pi over 2. So we're going to draw a dotted asymptote there. Now, I don't want you to get confused by this. This is the phase shift of the normal graph. Okay, so this asymptote, this orange one, is an actual asymptote of your graph. And then we have another asymptote at negative pi over 2. Now this is going to actually happen for tangent it's going to just keep repeating itself, this same distance here. Okay, and this distance here is the period because the period is just going to do the same thing every time. So this distance right here is pi. So every 8 boxes in this case, you're going to have an asymptote. So I'm going to count another 8 boxes here. 1, 2, 3, 4, 5, 6, 7, 8 boxes. We're going to have an asymptote. 8 boxes this way. We're going to have an asymptote. Okay, for as long as you have a graph. So every period, there's going to be an asymptote. So now let's plot these other points here. So we've got tangent of 0 is 0. So at 0, tangent is 0. Then at pi over 4, tangent is 1. So at the ordered pair of pi over 4, we're at 1. Okay, so pi over 4, 1. At negative pi over 4, we're at negative 1. So negative pi over 4, negative 1. And then these are just going to connect, and tangent looks like this. It curves in here, okay, and it can't cross those asymptotes. So what ends up happening for tangent is halfway between its asymptotes, it's at 0. Okay, then halfway between the 0 and the asymptote, it's at its amplitude. Okay, halfway between to the left, it's going to be at its negative amplitude. Okay, so if we have any shifts in the graph. So halfway between the asymptotes, 0. Halfway between to the right of the 0 and the asymptote, it's going to be at its amplitude. To the left, halfway between, it's negative amplitude. So your amplitude, again, remember, is your A value. So in this case, it's 1. So our amplitude is 1. The B value here is inside. This one is 1. Okay, the normal period for tangent is pi. So when you're figuring out the the period for tangent, it's pi over b. Versus for sine and cosine, it was 2 pi over b. Okay, your h is the number subtracted inside here. Your phase shift, there's nothing. So we started normal on the y-axis. Your k value is still the number added outside. There's nothing. So this vertical shift is 0, starts on the y-axis. So let's take a look at if we change the period here, okay? So we still have a 1A value, which is a 1 amplitude. We have no phase shift. So we have nothing subtracted in here. We have nothing added outside. So our starting points stay the same. Our amplitude stays the same. Now our period has changed. Okay, so remember, for tangent, period is equal to pi divided by the b value. This b value right here is 1/2. So we're going to do pi divided by 1/2. Okay, pi divided by 1/2 is 2 pi. So our b value is 1/2. Our period is 2 pi. So remember that tangent had asymptotes at pi over 2. Okay, so this scale is the same, 8 boxes to pi. So here's pi over 2. Here's negative pi over 2. Okay, the distance between that is pi. Now we need the distance between this to be 2 pi. Okay, with the middle still being at 0 because we didn't have a phase shift. Okay, so we need the 2 pi period split around this middle. That means pi is going to go this way and pi is going to go that way so that we have 2 pi total. Okay, so this asymptote is going to be over here at pi now, and this one's going to be at negative pi. That's going to give us a full 2 pi in between there. Okay, so it just stretched it out. Now, remember what I said about plotting these points. So halfway between your asymptotes is your 0. Okay, this is the middle of your tangent. Okay, halfway between at 0. Then halfway between the 0 and the asymptote. Okay, so halfway, so 1, 2, 3, 4, 5, 6, 7, 8 boxes. So 4 boxes. Halfway to the right, it's going to be at the positive amplitude. Halfway to the left, it's going to be at the negative amplitude. And then it's just going to draw a curve there. Okay, then to do a shift, so this one again has an amplitude of 1 because the B value is 1. This one or the A value. The B value is 1 here, so our period is just the normal tangent period of pi. We have nothing added outside, so our vertical shift is 0. But now we have pi over 4 subtracted on the inside, so our phase shift is going to be pi over 4. So figure out how big pi over 4 is going to be on this graph. Well, pi is equal to 8 boxes. So when we do pi divided by 4, that's going to be 8 divided by 4 boxes. Or 2 boxes. Okay, so here's pi over 4. So this phase shift is now going to shift over. This is the starting point of our period. Okay, so now our period for tangent is pi. Okay, so this one is pi. So that means that we need to have half of that going to the right and half of it going to the left. Okay, so half of that going to the left and right. Remember, pi is 8 boxes. So that means 4 boxes to the left, 4 boxes to the right. So 1, 2, 3, 4 boxes is going to be our first asymptote. 1, 2, 3, 4 boxes to the right, or to the left is going to be an asymptote. And then remember, those asymptotes are 8 boxes apart, or 1 period apart. So if we're going to keep drawing them, I would go every 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Draw in a asymptote. 1, 2, 3, 4, 5, 6, 7, 8. Draw in an asymptote. So those are a period apart. Then halfway between your asymptotes, remember, okay, halfway between your asymptotes is the 0. Halfway to the right, you're at the amplitude. Halfway to the left, you're at the negative amplitude. So halfway between here is the 0. Halfway between here, positive amplitude. Halfway between here, negative amplitude. Okay, 0, positive amplitude, negative amplitude. And then just connect with the curve and you'll have your tangent graphs.